All right, hello and welcome to our first video of the year. Today's lesson is on solving one-step equations, and so we are going to be adding in our first vocabulary terms today. You set up already that page 3 would be Unit A vocabulary. So now we're just going to add in a couple of terms. The first one is variable. So we saw this term already show up when we talked about combining like terms and distributive property, but I just want you to write in that a variable is a letter or symbol used to represent an unknown value. And once we start responding to some short answer responses where you have to identify the variable, you're going to use this sentence: let blank represent blank. So the first one is the letter we're looking for, or the letter we're going to identify, and the second one is the thing we're looking for. So, for example, we would say let G represent games if we're looking for the number of games to play. We would say let X represent a number if we were just looking for a number, and so on. So I want you to write that down. Remember, this is a video, so you are welcome to pause and go back anytime I'm moving too quickly for you. The next term is inverse operations. Now this one we will use today because those are operations that undo each other. And so that's how we get back to where we started when we are looking for an unknown. So when we know that we, for example, have a number plus 1 equals 3, we know that the opposite of adding is subtracting. So if I take that 1 back away, I would know the number they started with was 2. So adding and subtracting are inverse operations. They are opposite of each other. Now notice I do have a little back and forth arrow here because addition is the opposite of subtraction, and subtraction is also the opposite of addition. They are opposites of each other. To undo multiplication, we would divide. To undo division, we would multiply. And then these two you might not be familiar with, but we will see these this year. The opposite of squaring is a square root. The opposite of a square root is a square. The opposite of this one's cubing is a cube root. The opposite of a cube root is a cube. Now we won't see these show up today, but they are happening later in the year. The other part of the vocabulary page on the right-hand side is going to contain properties. So I'm going to scoot that on over. Remember, you could always pause this and go back. The properties you need to know about. So the first one is the inverse property of addition. This says that things together could equal 0. So for example, if I have A and I add in negative A, I would get 0 because these are additive inverses. So the opposite of A is negative A. When we add opposites, we get 0. That's the inverse property of addition. So over here, here's a little example. 4 plus negative 4 would be 0 because these are called additive inverses. The second one here, inverse property of multiplication. This word we heard last week, multiplicative inverse, which is the reciprocal of the original value, and those together equal 1 when we multiply. So for example, A times 1 over A would equal 1 because it would equal A over A. For some real numbers, 3 times 1/3 would equal 1 because 3 over 3 equals 1. And anytime you multiply a number by its reciprocal, those are called multiplicative inverses because together they would equal 1. So for example, here we'd get 63 over 63, which equals 1. Now the properties you are going to be using today, I have signified with these little equal signs. I want you to do the same. I will also be highlighting, so hopefully you've got your highlighters out because they are listed on the board as things to take out. So these next ones are the properties of equality. And so I want you to highlight these a little separately from the rest because these are our reasons for solving. These are the reasons we can do what we do with solving equations, the properties of equality. Now you'll notice I do want you to try to draw in this little scale because I want you to see it as a balance. So we do these things to both sides to maintain balance. So if it's equal, it's balanced. So the properties say that the addition property of equality says if I add the same thing to this side and that side, it'll stay balanced. Common sense. If I subtract the same thing from each side, it stays balanced. If I multiply the same thing from each side, it stays balanced. If I divide the same thing on each side, it stays balanced. So these are actually properties of equality. We have the addition property of equality, subtraction property of equality, multiplication, and division properties of equality. And they all have these entire words after them. We can abbreviate for now, but those are included in the property. So if we end up adding to both sides of an equation, we can say that the statement is true because of the addition property of equality. Now you should also have your workbook open to lesson 5A, so I'm going to show you that. Lesson 5A, students will be able to solve one-step equations. Students will be able to clearly state their reasoning with regards to finding the solution, and this is important for science problems involving forces acting on an object. All right, we just identified inverse operations in our vocabulary page as addition and subtraction being inverse operations. Multiplication and division are also inverse operations, and there's those properties of equality. Addition property of equality is when you add the same number to both sides. Multiplication property of equality when you multiply the same number on both sides. Subtraction, subtract, division, divide. So today we're using those properties of equality to solve equations, to figure out what the missing number was before they ever added, subtracted, multiplied, or divided. So the steps that I want you to follow are going to be written up here. So please write down number 1, draw the line. Number 2, circle the variable. Number 3, use the inverse. If you follow these steps, it makes it just a little bit easier to solve all these equations. I'm going to be scrolling past the rules for transforming equations, and we're going to our first example, number 1. So we see x plus 31 equals 10. So I told you the steps were draw the line. So we draw the line to separate the sides of this balance. You can see it as like a balance. And sorry if the video is shaky, by the way. Okay, so we're going to draw the line to separate the sides. Then we circle the variable so that we can for sure see where that unknown value is. So there's the unknown value. They added 31 to it, and then they resulted in 10. So since they added 31, we are going to do the opposite. We're going to use the inverse operation, and we are going to subtract 31 from both sides. And this is how I would like you writing it. And then we draw a little line here to see what our results were. So 31 minus 31 cancels out to 0. That's what we wanted to have happen, so that the only thing we have left over on the left-hand side is the variable x. We bring down the equal sign, and then we do this operation. 10 take away 31. That's going to go down into the negatives, into negative 21. So that's our answer. We'll put a box around it to kind of show the bottom of that balance. X should be equal to negative 21. And we got there using the subtraction property of equality. So up here, I'm going to write that this was our given. And this is, by the way, how you write a proof. This was given to us. X plus 31 equals 10. That's our given. The step we had to take to get to the answer was subtraction, and so we used the subtraction property of equality. And for now, we will just abbreviate these properties, but if you were typing it, you would have to type it out entirely. So we got there using the subtraction property of equality, and we can prove our answers correct if we check our work. So what I did was I took out the variable, and I put in what I thought it was equal to, negative 21. And we just check to make sure it actually does come out equal. Negative 21 plus 31 is the same as saying 31 minus 21, and that gives us 10, and it does equal the other side, which